The purpose of this video is to review the work done on oxidation numbers and redox, and it's meant to accompany the study pack. If you remember, I can think about compounds as being either ionically bonded or covalently bonded. An ionic compound is made up of positive and negative ions, which have an electrostatic attraction. Oxidation numbers is really an extension of this. An oxidation number is a measurement of the number of electrons that an atom uses to bond with atoms of another element. So clearly, in an element, irrespective of the formula of the element, no electrons are used to bond with atoms of another element because there's only one element present. So if I think about a formula such as Na or P4 or S8 or O2, it doesn't matter how many atoms are present in the formula. If there's only one type of atom, then clearly that atom is not using electrons to bond to another element. So we'll have an oxidation number of 0. So one way to think about oxidation number is to imagine, even though it's not strictly true, that all compounds are made up of a positive and a negative part. Now, as I've said, we know that this is not true. Some compounds are covalently bonded. So the charge on an ion is not the same necessarily as thinking about oxidation number, but there's clearly a link. So if you think about an ionic compound, overall, it has no charge. It's made up of positive and negative parts, but those bits, the positive bit and the negative bit, are in the same ratio as to make the compound neutral. Well, it's similar with oxidation states and oxidation numbers. We have positive oxidation numbers and we have negative oxidation numbers, but they will add up together so that the oxidation state of a compound is 0. We've already said that oxidation state is a measurement, or oxidation number is a measurement of the number of electrons that an atom uses to bond with atoms of another element. Now, in an element, in a pure element, there's only one type of atom present, and those atoms won't be bonded to another element, so the oxidation state of any element is also 0. H2, O2, N2, Na, Mg, S8, P4, they all have an oxidation number or an oxidation state of 0. The sum of all the oxidation states in an ion is equal to the charge on that ion. Now the next bit, the oxidation state of oxygen is -2 when in a compound or ion. So oxygen as an element, O2 gas, would have an oxidation state of 0 because it will be an element. But when you have oxygen inside a compound or inside an ion, it has an oxidation state of -2. When you think about oxygen inside compounds, ionic compounds, it would have a charge of 2-. There's a slight difference there, isn't there? -2 for oxidation state, 2- for the charge on the ion. So when we're talking about a formal charge, the number is followed by the sign. When we're talking about an oxidation state, we have the sign followed by the number. Similarly, when hydrogen is inside a compound, it has an oxidation number of +1. That's when it's in a compound or inside an ion. When in compounds, group 1 elements have an oxidation state of +1, group 2 elements have an oxidation state of +2. Again, that will be similar to the charge, wouldn't it? If we think about group 1 elements when they're inside a compound, an ionic compound, they have a 1+ charge. And group 2 elements, when they're inside an ionic compound, they have a 2+ charge. So there is a clear similarity here. Now, the last point, it's a bit vague this, sometimes the oxidation number of a group 7 element can change. But generally speaking, unless we've been asked to find it, we can often assume that it has an oxidation state of -1. That last point's a little bit shaky. All the points up to that are things that you need to really learn. There are some exceptions to these rules. For example, when oxygen is in a peroxide or when you have metal hydrides. We'll deal with those as we come to them. So now in your study pack there are some worked examples. If we look, for example, at sulfur dioxide, SO2, and the question is, what is the oxidation number of sulfur? Well, SO2 is a compound, so the oxidation numbers, the oxidation states, of all the elements present must add up to 0, because it is a compound. We must have positive oxidation numbers and negative oxidation numbers in order for it to total 0. Each oxygen, by a rule, always has an oxidation number of -2. As there are 2 of them, that would add up to -4. So that means the sulfur must have a +4 oxidation number. An alternative way of thinking about it, and perhaps an easier way, rather than drawing out a table, would be to say that sulfur plus 2 lots of oxygen, well, we know oxygen is -2, must equal the overall oxidation number, which clearly, as it is a compound, is equal to 0. So sulfur -4 equals 0, sulfur equals +4. Writing out as a formula probably makes it an easier way to calculate what the missing oxidation number is. In this second example, we're going to do the oxidation number of sulfur inside an ion. Now again, there's a table method here. It's a bit long-winded to be doing this in an exam situation, so I'll show you how to do it as a formula. What we're saying is sulfur plus 4 lots of oxygen. Now remember, oxygen inside a compound or an ion has an oxidation number of -2, must equal the oxidation number of the ion as a whole. And we can see that this ion has a 2- charge. So the oxidation number is -2. So what we're saying is sulfur plus -8 equals -2. So sulfur equals +6.